Assalamu alaikum everyone. This is lecture 16 for CS116 Object Oriented Programming. In last lecture, we studied this specific concept of polymorphism called operator overloading, and there we learned that how we can make our classes look more like the built-in classes, like how we can use those user-friendly operators like assignment operators and arithmetic operators and comparison operators with our own objects, with our own user-defined objects. Now, there are a couple of small but relatively advanced topics left in polymorphism, like duck typing and how to make abstract classes or abstract methods. But we'll defer it for the next week because they require a couple of prerequisite concepts or prerequisite topics that we need to understand. So, in today's lecture and in the next lecture, we'll study those prerequisite topics and we'll practice them, right? In today's session, first I'll talk about functions again. We know a lot about functions, but today we'll see how we can pass these functions as parameter to another function, so or to other functions. Now, I think I discussed this concept briefly in last semester as well, but uh, I don't actually remember. But today we'll discuss this in a bit detail, and this concept will then help us understand another concept which is called decorators. So decorator is a relatively advanced concept in Python, and it's a actually Python specific concept, not an object oriented specific concept, but it will help in implementation of some of the features of object oriented programming in Python. Um, we have discussed this many times in Python that everything in Python is an object. Uh, Same is the case for functions. Functions are also a kind of objects. In fact, they are considered as first class objects in Python. By first class object, I mean that they can be manipulated the same way as other objects can be manipulated. Like you can assign objects to variable names, you can store them in data structures, you can pass them to functions, you can return them from functions, etc., etc. So, uh, to explain this, I'll show you examples, different examples, and there we'll see that how you can manipulate functions uh, like like you manipulate any other object. In this first example, we'll see how we can assign functions to any variable or to any variable name. Now, in this example, I'm defining a function called func object or function object, and this function prints this statement: I am a function object, and that's all what it does. Now, if I write this statement, this is the way we had been using functions previously, in fact all the time. What this statement will do, it will simply call this function func object, and it will execute it, and whatever is returned from that function will be assigned to value m. Now, since this function is not returning any value explicitly, so that means it will return a none value. I hope you remember this, that whenever you do not explicitly return anything from a function, that returns a none by default. So this is what will happen. This function will be executed by this statement, and the return value will be assigned to m, which is none in this case. Okay, now this I am function object is actually printing because that line was there inside that function. So when that function is executed, it simply prints this on the output. Now, in this second statement, notice that I'm not using those round brackets at the end. That means I'm not executing this function. So what this statement will do, it will assign, or actually it will link this function object or func object to s. So that means here you are manipulating this function as an object. So it will not execute the object, or it will not execute the function, but it will consider this function an object, and that object will be assigned to this variable name s, and in fact it will be linked to this variable name s, right? So this is what it will do. It will not execute it. So if I write another statement, this, so this statement will now execute the function, because s means func object and you are putting those round brackets after it, so that means it will execute that function. So this is equivalent to calling that func object. Now since now you are calling that object, that means that line I am function object will again be printed at the output, right? And if you print s only, here you see I'm not using those round brackets after s, so that means I'm not executing the function. So s will be treated as a simple object. So if I print it, this is what I get. And I hope this notation is kind of familiar to you now, because it shows that this func object, it is a function and it lies at this particular hex address in memory. We know that normally a function is a user defined function or a user defined class is printed this way, right? So here what I wanted to highlight is that a function, it can be treated as a simple object, and when you are treating it as an object, what you have to do, you just don't put those round brackets after it. So if you are putting those round brackets, that means that function will be executed, and if you are not putting those round brackets, then that function will be treated as an object. Now the second example demonstrates how we can pass a function as a parameter to another function. So I'm defining the same function again, func object. It does the same thing. It prints this line, I am a function object. And here I'm defining another function, and it is called func a, and I'm passing it an object x. And in the first statement, what I'm doing, I'm simply printing that object x. So whatever object it is, it will be printed on screen. So if you are passing some built-in object like integer or string or list, it will be printed in their respective forms. And if you're passing a function here, what will happen, that that function will be printed as an object, as we saw in the last slide, right? I'm adding one more statement here, this. Now if I do this, that means that any object that has been passed to func a is expected to be a function. That's why I am putting those round brackets here. So if it is a function, then it will be executed, and if x is not a function, then this line will give error that no such function is found, right? So let's um use this function and see what output it produces. Now this statement will call this func a or function a, and what I'm doing here, I'm passing func object as parameter to it. Now again notice here that I'm not using those round brackets after func object. That means func object is passed as an object to func a, right? So if I execute this, what will happen, func a will be executed first, x will be assigned func object, and when I print x, that means func object will be printed as an object. So this is the output that it will produce, because func object is printed as an object. So this is how it will look. And the second statement in func a, there I am putting those round brackets after x. Now here, right now, x is equivalent to func object, so putting round bracket means that I'm executing func object. So since now I'm executing func object, that statement I am a function object, that should be printed on screen. Okay. Now there is an alternate way of doing this. I could have assigned func A to S, because if I'm doing this, we know from the previous slide that func A will be treated as an object, and that will be linked to this variable name S. And then I can pass S as a parameter to func A. So this whole example too, it simply demonstrates that func object or any function, it can be passed as a parameter in any function, and this is the same way you pass any other object. So functions can be treated as an object, can be treated as objects, and you can pass them to any other function, treating them as objects. In this last example, we'll see how a function can be returned from another function. So as we saw while passing functions as parameters, that whenever a function is passed as a parameter, it is passed as an object. Same is the case with the return statement. Whenever you return a function, you are actually returning that function as an object. So let's see that. This is that same old function, func object. It is doing the same old thing, printing this line. Here is another function, func C, and this function simply returns this func object. Again, notice there are no round brackets at the end, so that means this will be returned as an object. Okay, so here it is a statement in which I'm calling func C. So what I'm doing here, I'm printing func C with round brackets. That means since I'm placing those round brackets after func C, that means func C will be executed. So first we'll go to func C and we'll see how does it execute. It simply returns func object. So here, since I'm not putting those round brackets after func object, so func object will not be executed. It will simply be returned as an object, and that returned value will be printed when this print statement, this last print statement, will be executed. Right, so func C is executed, it returns that func object, and that object will be printed on the screen. Okay, like this. Now let me show you one more variant of func C. Here, if you see in return statement, I'm using those round brackets at the end. So that means that func object will be executed. So whereas in the last variant, uh, I was not using these round brackets, and I said only object of this func object will be, or func object will be returned as an object. But in this second case, it will be executed because I am putting these round brackets. So what will be returned by this new func C? It will call this function func object. Func object will be executed, which will print that line at the output. And what it's returning none. So that none will be returned, and that none will further be returned by func C. So if I write this statement, so func C will be called, func C will call func object will be called. When func object is called, this statement is printed at output. Here it is. And since it's not returning anything explicitly, so none will be returned. So none will come to to replace this function func object in func C. So that none value will be returned to the place from where this func C was called. That means that print statement. So actually now this print statement will ultimately print none, and this none is coming from func object. See, so there is a difference. Like when you put those round brackets, you are actually executing a function, and when you are not putting those round brackets, that means then you are treating that function as an object. So here what it did, right? So the main takeaway point is the same, that a function can be treated as an object, and when you are treating it as an object, don't put those round brackets around it. And whenever you want to execute it, you just put those round brackets after it. It will be executed normally then. Now, whatever we just recapped about functions right now, that will help us study this another concept called decorators. Now, decorators, they are a relatively advanced concept in Python, and I'll try my level best to explain it to you in the simplest possible manner. So what are decorator? A decorator is a tool for adding new functionality to an existing object without modifying its structure. uh, this object, it could be a function or it could be a class. So for example, you have a function and you want to use it in some class or in some other function, but you want to add some functionality to it only for that specific use. So you don't want to change that original function permanently, you just want to add some temporary functionality to it. So you can do that using a decorator. These decorators, they can be of two types. Either we can have function decorators or we can have class decorators. What are function decorators? They simply augment function definitions. By augment, augment actually means to add. So a function decorator will add some functionality to an existing function. So what it actually does, it puts that original function into a wrapper, and that wrapper is providing some extra functionality. So your original function remains same inside the wrapper, and wrapper actually extends the functionality of your function. I'll show that to you shortly through an example. So they are actually acting like meta functions. By meta function, we mean functions about functions or functions around functions. Class decorators do the same thing to classes. They augment a class definition, they add something to existing class, and you can use a decorator to extend its functionality, and they can be called meta classes, like classes about classes. Right now, function decorators, they are more commonly used and they have more applications as compared to class decorators. So we'll discuss only function decorators in this lecture, and at some point of time later, if you choose to become Python developer, you can always see what class decorators are. They work in the similar manner, but the concept is applied to classes instead of functions there. In decorators, functions, they are taken as arguments into another function and then called inside a wrapper function. Decorators, they are usually called before the definition of a function you want to decorate. Now, the best way to explain these 2 points is through syntax or example, which is coming on the next slide. For now, let's see what components a function decorator should have. Uh, we define a decorator first, right? You write definition for the decorator. You define your function and you use a decorator along with that function, right? And then you call the function. So when you call a function after decorating it using some decorator, then the meaning of that function changes. Now let me show you through an example. Let's first discuss some syntax. First, let's see how I can define a decorator. So for defining a decorator, you simply use those function definitions. Def is the keyword for function, and decorator, it could be any name, the name that you want to give to your decorator, it could be anything. And in brackets, you pass a function, right? You pass a function as an object. We just saw that functions, they can be passed as an object, so you will be doing that here. So this is a decorator function and it is accepting uh, a function object, right? Now, inside this function, you define another function, and that function is the wrapper function. You can name this function anything, but here I'm calling it a wrapper function. This is an essential function that you have to define within a decorator. Now, inside this wrapper function, you can write whatever code you want to add to to that original function. You can call that original function. Now you see one thing here, I can call that function that has been passed to my decorator, because if you remember LEGB rule, this wrapper function is nested within the decorator function. So since it is a nested function, that means it can call any object from decorator function. It's not changing that object, it cannot change that object, but it can call that object. So I don't need to pass that function from decorator to wrapper. Wrapper already has access to that function. So you can call the function, you can add more code. See, that's how you are wrapping some additional code around your function. You added some code before calling your function and you added some code after calling your function. So that means wrapper is wrapping your function in a layer of some extra code, right? So that's all what a wrapper does. And then from decorator function you return this object wrapper, right? So here the fixed format is that you define a decorator using two functions. One is the outer function, which is the main decorator function, and then is the wrapper function. You can name it anything because this is not actually accessed from outside by user, so user doesn't have to know what name you are giving to your wrapper function. But decorator's name is important because user should know a name of that decorator so that it can be used. So it's a two-layer function. Inner function is the wrapper function. You put your function and any wrapping code around it inside the wrapper function, and your main decorated function simply returns that wrapper function as an object, right? Now, here is the syntax to call a decorator. To call a decorator, we use a keyword at the rate. So, at the rate followed by name of your decorator, that will do the magic. So, whenever you put this statement above any function definition, that function will be passed to the decorator. Actually, these two statements, they are equivalent to this. You define a function definition and then you pass your function to this decorator. So these two statements are equivalent. So see what you are doing here on the right hand side code, you have defined a function. Let's call it function, and then you pass that function as an argument to your decorator. So you see your function has been passed as an object to decorator, and then decorator calls wrapper. Wrapper wraps your function or put some additional code around your function, and then wrapper is returned. So that returned wrapper is assigned to this function on the left hand side. That means when you return from decorator, you are actually holding a wrapper kind of object, not function kind of object. So after returning from that decorator, your function, this variable or this variable name function, it will contain or it will point to a wrapper object. Now you can see that those two statements on the last slides, they make sense now. So decorator is a function that takes another function as an argument, and that another function that has been taken as argument, it is passed to a wrapper function and it is actually executed inside that wrapper function. So this is what's happening in the definition of that decorator. The second statement there was that we usually define or write that decorator statement above function definition. So you can see that at the rate sign in syntax to call the decorator, that at the rate sign and then decorator name, so you are placing your decorator above the function. Although there is this right hand side's alternate way too, but the left hand side's method is more convenient and is used more frequently. Now coming to the third component, how you can call this decorated function. You call it normally like you call any other function, just this function call. So apparently you are trying to call your own function, but since you have decorated that function, what will happen, this statement, in this statement, this word function, it does not actually containing your functions object. After decoration, it contains wrappers object. So, and what is a wrapper? Wrapper contains your function as well as some additional code. So once you have decorated your function, what you are doing, you are actually assigning your function name to the wrapper. So let's see a detailed example, and there I'll show you line by line how this is working. Now let's convert that syntax into some proper code which can be executed so that we can run it and see some output. So here I am defining a decorator. The name of my decorator will be my decorator, and I'll use a function my func, and I'll decorate this my func with this my decorator. So let's see how we can do it. First step that I'm doing here is I'm defining my decorator. Now from last slide we know how can I define my decorator. I need to define a nested function. So this is the first line. Here I am defining it like any other function. The only difference is there that in brackets I am passing a value which is expected to be a function. Actually I'm passing an object which is expected to be a function. Now the second statement will be of nested wrapper function. So here is my wrapper function. I can name it whatever I want because this is not visible to the user outside. So let's call it my wrapper. Okay, inside this I am printing this statement wrapper before function execution. So this is something that I'm doing other than my function. So after this I'm calling my function. Now this is the object that has been passed to my decorator from the caller. So obviously if I'm passing my own function or my func to it, then this last statement will be replaced by my func round brackets. And because of LEGB rule, there is no issue in this. This func will access that object that has been passed to my decorator. And after executing this function, I am printing some more statements here, or simply another print statement. So these two print statements, they will be printed around my function. That's it. That's the role of my wrapper. And after that, I'll come out of this inner function wrapper, and in the my decorator function, I'll simply return this object, my wrapper type object, to the caller. So this is how I define a decorator using these nested functions. Now the second thing is how can I call it? So this red code will show you the second step. See this @ my decorator. That means I'm going to decorate my function using this statement. Here @ is a keyword. And after that, I am defining my function. So here is my function, my func, and there is only one statement inside it, and that will print this decorated. So, okay, and there is an alternate way of doing this. I can define my function first, and then I can use this statement. This statement is equivalent to that @ operator. Oh, the only difference is that you put that @ operator statement before function definition, and in the right hand side code you put this assignment statement after your function definition. So but this right hand side code is more illustrative, although left hand side code is more easier to use. So what's happening, whenever you use that @ sign, my decorator function will be called, and your function will be passed as an object to um, as a parameter or as an object to my decorator. Then my decorator will call my wrapper, and then my wrapper will be returned as an object which will be assigned to my function. So that means after execution of this decorator, the definition of my func will change. So in the last step, what I can do, I can simply call this function. So here apparently I am calling my func, but since I have decorated my func, so actually I am calling my wrapper over here, right? This is what I tried to explain you in last slide as well. So let's see how this code executes stepwise. Now let's run this code carefully line by line. We know that whenever Python scans a file that contains functions code is not executed while that's scanning, because unless a function is called, that code for function is a dead code. So when Python starts reading this code, that's the blue portion, that means it's just scanning that portion for syntactic errors. It's not actually executing that code, because I'm not calling that my decorator function there. That is called later. So unless it is called, that means for Python, it's just a dead code. So Python will start scanning these blue lines one by one for syntactic errors. After this blue code has been executed, it will come to that red portion, and there it will encounter that statement at the rate my decoder, my decorator, and followed by that function definition my func. Now this at the rate my decorator is an executable statement. It will decompose into that statement on the right hand side. My func is equals to my decorator, and my func is passed as an argument to it. So when this statement is executed, what will happen? My decorator function will be called, and this object my func, which is the object of my function which I want to decorate here, that object will be passed to this function my decorator. So this is the first statement that will be executed. Before that, Python was just scanning all those statements for syntactic errors. So this is the first statement that will be executed, because here actually I am calling this my decorator function. So when this my decorator function is called, the object or my func is passed as an object um, to my decorator. So this is step 2. We'll come here, and then this function will be executed. Now you see, inside this function we are not calling my wrapper function. So my wrapper function is not called inside. That means the code inside my wrapper will not be executed. So this is step 3, but we will not run the code inside my wrapper. We'll directly come to this return statement. And what this return statement is doing, it is returning my wrapper as an object back to the caller. And who the caller was? My decorator was the caller. So now my decorator will receive this return value, which is actually my wrapper object, and that will be assigned to my func in step 1. So this is what will happen. Now my func is equals to my wrapper object, right? Now that means my decorator has been executed. Now Python will come to the third part, that is the black code. This is step 5, and here my func is executed. And how do we know that it is executed? Because I'm placing those round brackets after it. Now apparently my func means that my function will be executed, but that decorator statement has changed it to my wrapper. So although I'm calling my func, but actually my wrapper will be executed. So this statement my func round brackets is actually equivalent to my wrapper and those round brackets, right? So that means now this wrapper function is actually called. So step 6 will be this one. So now this function is called, and actually it is executed. So we'll go inside this function. This is the first statement, step 7, and this is a print statement. So it will produce some output on screen. It will simply print this wrapper before function execution. After that, this is step 8, which is called to func. Now what is this func? Decorator, my decorator actually set it to my func. So calling func means now I am calling my actual function my func. So this is step 9, and this is step 10. So this is again a print statement. So it will print decorated on screen. After that, we'll come back to step 8, because that's the place from where this function was called. And then we'll execute the next statement, which is again a print statement. So this will print this output on the screen, and here it will end, because what we were doing that in step 5 we were calling my func, and my func was actually calling my wrapper, and now at step 11 my wrapper has been executed completely. So here it will end. Okay, let me show you one more example. Here I am applying it to a more practical scenario. Here I'll write a decorator, and that decorator will find or calculate runtime of a function. So if I am decorating a function with this time decorator, then what I'll get to know how much time my function took in execution. So first let me write the decorator. Actually I'll be using some functions from this class time, so I have to import this some really simple functions. Now this is my decorator. I am naming it calculate time or calc time, and I'm passing it a function object. Actually it could be any object, but the way it will be used inside this function calc time, that shows that it has to be a functional object. Okay, then this is according to the format, I have to place a wrapper function inside. And okay, in this wrapper function, what I am doing, I am calling a function time from this module time, and this function simply returns the current time of the system. I'm not concerned with the format, like in which format does it return this time, because that won't matter, you will see that shortly. So it will return the current time from my system, and that will be value will be assigned to this variable name began. Okay, after that I call my actual function, right? And once my function has been executed, I call this time function again, and I assign it. This time I assign this value to another variable name end. So that means begin contains the time at which my function started executing, and end is the time when my function stopped execution. So if I find the difference of these two variables, end and begin, that will give me how much time my function actually took uh, uh, while executing. So I am simply printing that difference. So this means that this wrapper function is putting some time collectors before and after my function, and it's simply printing that difference. So whatever function I pass to it, to this wrapper, or whatever function I decorate using this calc time decorator, for that this particular statement will be printed, which will show its runtime. And this is again part of the syntax that you just return that wrapper function. Okay, this is all about the decorator. Now what I have to do, I have to define my function and decorate it. So this first statement is the decorator statement, and we place it before function definition. So I am writing this first, and then I am writing or defining my function. This is my function long loop. uh, it does nothing. It only prints this statement, take your time, and then hit any alphanumeric key to exit. So actually, you'll take some time in hitting that key. So that time will be printed by my decorator. So this input is just there so that this long loop function waits for you to hit a key. I think there is nothing difficult in this function. This is quite self-explanatory. Now the third step is when I call it. I have already defined my decorator. I have defined my function, and I have long loop, and I have decorated my function long loop with that decorator calc time. And since I have decorated it with calc time, that means that now when I call long loop, I won't be calling long loop. I'll be calling that wrapper function instead. So if I write this statement long loop, what it will do, it will call that wrapper function. That wrapper function will find system's time before executing my function. Then it will call my function. In my function, it will wait for me to input any key. So it's upon me how much time I take in responding. And after that, it again note finds the system's time, and that's how it sees that how much time I had taken to respond to that input statement. So I hope this is an interesting example. I won't show you the output here. You can find the code in that code file, and you run it by yourself and see what you get. So in last couple of examples, we saw how we can write our own decorators. So you can always design some useful decorators, like the one we saw in last example, that was calculating runtime for a function. That was really, really useful, and it could come handy in many scenarios, especially when you will be studying courses like data structures. There you'll be doing this a lot of time, like you'll be calculating runtime for various functions. So there you can use this decorator. Then you can write a decorator that logs the event history for a function, like how many times you called that function, with what arguments you called a particular function. So or what kind of arguments you pass to that function. And if you keep log of all those things, what will happen, that will ultimately help you in debugging code. We'll talk about this event logging more in the last week. There, obviously, we'll use some more decorators to implement that concept. For now, one additional information for you guys is that there are some built-in function decorators too. So Python provides some built-in function decorators that can be used at various places, and two of them will be used in the next lecture. So discussing all this was for this particular point. Um we can use a decorator. There is a decorator available that can make your method a static method, and there is another decorator available that makes your method a class method. Now, static methods and class methods, these are types of methods that can be defined within a class. Up till now we have seen that we can have three types of variables in a class: instance variable, class variables, and local variables. Similarly, we can have different types of methods in a class as well. So the three types of methods that we can have are instance methods, that we have been using since start. Then we can have static methods and class methods. So these two new types, static methods and class methods, this is going to be the topic of our next lecture. So obviously we'll use these decorators to implement these methods there. Okay, this is another built-in decorator available in Python. It is used for defining properties. If you can recall, I use this term for attributes. This is an alternate term for attributes. So what happens when you define a property? You are actually automating the setters and getters for a specific attribute or for a specific property. So again, this is another advanced concept in Python. And let's see if I can fit this topic anywhere in the remaining part of this course. Otherwise, you can learn it by yourself whenever you need it. So the main thing, or the main topic that we discussed today, was decorators. And we first saw that how functions, they can be passed as an object to or from other functions. And this concept is used in implementing decorators. And why we require decorators? They actually are a very handy tool which can add some functionality to an existing function without changing it, right? So it's a difficult concept, but if you grasp this concept, it will help you understand many other things later in this course and later in Python in future. So that's all for today. Thank you.